material is found in reservoir water from the degradation of plant microbial matter. The presence of this natural organic matter in water can cause bad odor, color, and taste, as well as increasing the potential for disinfection byproduct to form. Due to the range of degradation pathways, the character of the organic matter is complex and can vary significantly in both hydrophobicity and charge. Water treatment works abstract water from reservoirs and therefore must remove the organic matter. The process utilized for this is coagulation. Coagulation is needed as a negative charge in the organic matter causes repulsion. This makes it difficult to remove. In order to remove the organic matter, a positive coagulant, which is generally a metal salt, is added to the water. In this example, aluminium sulfate has been added. The positive charge in the coagulant reduces the overall charge of the organic matter, allowing them to flocculate together. The flocculated organic matter is then removed using dissolved air bubbles, which push them back to the top of the vessel where they can be more easily removed. The amount of coagulant which is dosed is according to the grab samples resulted from jar tests. These jar tests aim to mimic the dynamics of a full water treatment works in a 1 liter jar with a spinning metal paddle. Varying concentrations of coagulant are added to the water, and after the test, each treated water is analysed. This coagulant dose from the jar will then be used to dose at the site. The major issue, however, is the tests are generally performed infrequently, and due to highly variable incoming water, this means that a lot of water is not being optimized correctly. Another option, which several treatment works have opted for, is to move to online monitoring. Generally, an ultraviolet light is used at a wavelength of 254 nanometers. The absorbance of this light is then translated into an estimate of the organic content of the water. This method is better than jar testing as it allows for constant monitoring of the raw water. However, there are also issues with the ultraviolet technique. It's mainly the aromatic fraction of the organic matter, which absorbs light at 254 nanometers. The aromatic fraction is majorly found in the hydrophobic region, which is more easily removed. However, as previously touched on, the character can change significantly or can lead to an under or overestimation of the amount of coagulant needed. As you can see, the coagulant process is a charge neutralization reaction, and therefore it's hypothesized that by determining the charge load of the raw water, a milli equivalence ratio can be formed between that and the coagulant being dosed. Fortunately, there is no online methods to measure charge density. This research will determine the relationship charge exerted by the organics and charge delivered by the coagulant to be used for control dosing. The research will determine the relationship between the charge, organic matter, and treatability in a laboratory setting. Fractionation will also be used to determine how the hydrophobic fractions affect the charge analysis. A range of surrogate measurements will then be investigated to determine the relationship with the charge. These surrogates will then be compared to online instrument data received from the live water treatment works. The next step of this research will then produce an algorithm based on the charge of incoming water and dose coagulant accordingly for optimal DOC removal. This research focuses on utilizing existing water treatment works assets and bringing them into the 21st century by implementing real-time technology and utilizing the data to ensure a more optimized and resilient treatment works.